The most amazing thing about our universe is its size. How unimaginably big this universe is. But this is also the most disappointing thing. Think about it. If today we use our powerful telescopes to find another planet like Earth in a galaxy, which is suitable for humans, it will take centuries to reach there. Welcome again to Mr. Dar Videos. In fact, it is impossible for any individual person to leave this galaxy. Now everyone knows that the Earth is in the Milky Way galaxy. And the closest galaxy to the Milky Way is the Andromeda galaxy. Approximately 2.5 million light-years away from the Earth. So if we use a spacecraft to reach there, the usual speed of a spacecraft is 28,000 kilometers per hour. It will take 94.5 billion years to reach there at this speed. Not only that, if we somehow make the technology to travel at the speed of light, it will still take 2.5 million years to reach there. This is really disappointing. After all, what is the point of exploring all these planets when we will never be able to travel there? But if there is a shortcut to travel outside the galaxy, a shortcut through which we can complete this journey of 1 million light-years in a few months, then these things definitely become interesting. These shortcuts are wormholes. The 2014 film Interstellar, my favorite space film, I would like to mention here. In this film, it is shown that when Cooper and his team leave Earth in search of more habitable planets, like Earth, they travel to another galaxy. From their own galaxy to another galaxy, they reach through a wormhole, within a few minutes. This is the scene of the film when Cooper's team passes through the wormhole. According to the film, this wormhole was discovered near Saturn's orbit by NASA. It is mentioned many times in the film because it plays an important role in the plot of the film. But the most interesting thing is that this concept of wormholes is not science fiction. In fact, it is based on real science. What are wormholes exactly? And how can we use them? Before understanding all this, we have to come back to Einstein's theory of relativity. When Albert Einstein wrote his theory of relativity, it was written in a set of equations. The set of these equations is called Einstein's field equations. It was revealed to the public for the first time on November 25, 1915, when Einstein submitted his paper to the Prussian Academy of Sciences in Berlin, Germany. In total, these field equations are made up of 10 different equations. 10 nonlinear partial differential equations. But they can also be represented by one equation in short. And that one equation looks something like this. Basically, this equation tells us how matter and energy influence the curvature of spacetime. Albert Einstein had said to visualize this thing, imagine a big mesh. When you place objects on this mesh, it bends down from the weight. The spacetime mesh also bends in the same way. It gets curved. Because of the weight of big planets and stars. The more the gravitational force of a planetary object, the more the spacetime mesh will get curved around it. Now, the interesting thing is that Albert Einstein himself was not able to solve his field equations properly. He just came up with an approximate solution of his equation in a specific case. The first person to solve these field equations was Carl Schwarzschild in 1916. He calculated exactly how much the curve of spacetime bends in the case of a single ball of mass. This was the solution of Carl Schwarzschild, which helped scientists understand the concept of singularity. What will happen if this mass becomes infinitely dense? The curvature of spacetime will wrap around it so tightly that this region will get completely pinched off from the rest of the universe. Because of this, scientists were able to theoretically prove the concept of a black hole. And this was 100 years ago. Actually, it was the first time in 2019 that a scientist took a photo of a black hole. So, a solution of these field equations was black holes. Theoretically, we already knew about the existence of black holes about 100 years before they were discovered. And the thing is, there is another solution of these field equations, which are wormholes. Wormhole is one solution. And the scientific name of the wormhole solution is Einstein-Rosen bridge. This name comes from Albert Einstein and his assistant Nathan Rosen, who together came up with this solution in 1935. Understanding the wormholes is very easy. It is basically a shortcut that connects the 2 points of spacetime. As Einstein said, the shortest distance between 2 paths is always a straight line. In our three-dimensional world, we think the shortest route to go from the Milky Way galaxy to the Andromeda galaxy is 2.5 million light-years away. But if our three-dimensional space is curved in the 4th dimension, if it is bent, then it is possible that a bigger shortcut route can emerge. Now, it is very difficult for us to imagine the 4th dimension because we all live in 3 dimensions. When you search the word wormhole on the internet, you will see many such diagrams in a nutshell, connecting 2 points through a hole. Here, it is being imagined that there is a mesh of spacetime, and there is an object on it which has a lot of gravitational force. So much so that the curvature of spacetime has bent so much that it has come out from the other side, the mesh of spacetime has folded on itself on a cube. And this wormhole has become a shortcut for traveling from one galaxy to another. But in all these visualizations, there is a problem of dimensions. A wormhole has been tried to be represented in 2 dimensions. But as I said, the wormhole works in 3D to 4D. So in reality, if a wormhole ever exists, it will look like a spherical ball. There is a very interesting website where you can visualize how wormholes actually look if their existence is proved. A ball-like figure, where as you go inside, things look curved around you. And if you turn around and look, the Earth is also moving away from you. And everything will look in a circular shape. That's why the wormhole shown in the Interstellar film has been depicted in a very realistic way. It is important to say that the concept of wormholes, for now, as of 2024, is just a theoretical concept. It has been theoretically derived as a solution to Einstein's field equations. In movies, it has been tried a lot to be visualized by scientists. A lot of theories have been made on it. But practically, no one has ever seen a wormhole. Scientists don't know whether wormholes actually exist or not. But if wormholes exist, they will also work as a time machine. Because imagine, in a few minutes, you can travel millions of light years away. This means you have reached there before the light. If the light doesn't reach there, then basically, you have jumped from one place to another in time. Now, that's a different matter. If wormholes exist, can humans travel through them or not? Practical problems arise here when we consider wormholes to be true. The question is, how will the opening of the wormhole be made? We need a very heavy gravitational force here. Where will this gravitational force come from? Yes, the answer is a black hole. Einstein and his assistant Rosen theorized that only black holes can have such a gravitational force that they can open up the tunnels of wormholes. Everything is attracted towards the black hole. Everything will be attracted towards it and will flow through this wormhole. It will go through this tunnel. But the next question is, what will happen on the other side of this tunnel? If there is a black hole on the other side, there will be no way out of this tunnel. You will be trapped inside it. Basically, this wormhole will not be a tunnel. It will not be a tunnel to go from one side to the other. Instead, it will be a place to trap you. Something like this should happen on the other side, which is opposite to the black hole in every sense. Something that is as powerful as the black hole, but works in the exact opposite way. Instead of attracting things towards itself, it should send things away from itself. So that an exit point can be created. And here, in our story, there is an entry of white holes. I hope you will like and share this video. We will soon make a video about white holes. Stay tuned for new videos. Take care of yourself.